Okay, hello Calc 2 enthusiasts that don't exist. This is problem set 5, week 11 or something. At the top here I have the 3 types of comparisons I was planning on using. I used a few other ones. Starting with problem 1, you have your series k equals 1 to infinity of 7 to the k over k factorial plus 10. This one I used the comparison test, just kind of took out the 10 and got 7 to the k over k factorial. Then I did the ratio test using the limit as k approaches infinity. You take the absolute value of that. In this case, I didn't really need to because there were no negatives, but I still wrote it out for solidarity, I guess. Following it through, doing your basic algebra, you end up with 7k or k factorial over 7k. Over here, I just multiplied by the reciprocal and whatnot to get rid of them. And then you get your final answer of 7 to the first power over k plus 1. Plugging in infinity, that equals 0, making L less than 1, which means it's absolutely convergent. Probably could have explained that better. Number 2, you have your series, your infinite series, k equals 1. The negative 1 to the k just makes it alternating. Natural log of k is just kind of like a, it's not exponential, so it's a number you don't really need to worry about. And then over k to the 1/3, which is the same thing as k, or k to the 1/3 is the same thing as k to the negative square root, cube root, I believe. Sorry, I don't know why I'm trying to explain that, but this one was relatively easy. You just use your knowledge of p series. The negative 1 to the k shows it's alternating. The p series being less than or equal to 1 means that it's divergent. For number 3, you have your infinite series, k equals 1 of k to the 4th over e to the k to the 5th. For this one, I used the, I keep forgetting what things are called. This one's not ratio. I believe this is the integral test. E to the x to the 5th is the same thing as e to the negative x to the 5th. I used u substitution for this one. Dx equals 1 over negative 5x to the 4th. That makes it really easy when you just plug it right back in. So you get x to the 4th times e to the u times what you put in for your dx, and then I forgot to write out a du right here, so please don't deduct points for that. And then after combining them out, you get negative 1/5 e to the u, because the x to the 4ths cancel each other out, which is good because you don't want x's and u's in the same thing. And then you keep solving it out, doing your basic algebra, find the integral of your final-ish answer right here. Integral equals this. And yeah, that shows that it converges as that equals 0. Lastly, I used the limit comparison test, I think it's called, for number 4 for the infinite series of k equals 1 natural log 2k plus 1 over 2k plus 4. When you plug in the limit, you get 0, which is less than 1. Or actually, this one might be wrong. I think the natural log of this is actually negative 1 point something, but that's still less than 1, showing that it converges.